My dear students, we are going to discuss the questions from the NEET, and the first chapters which we are going to take is some basic concept of chemistry. And the first question from this chapter is to find out the maximum number of atom from the given option. So for this question, we will take a general formula which is given weight by molar mass into Avogadro number into atomicity. So this is the general formula which is applied for all the option. Let's take option A, 1 gram of Mg, which is given weight is 1 and molar mass is 24 as given in the option also. Avogadro number, we'll write only Na because the Avogadro value for it's same for all the option given here. The atomicity is 1, so it is 1 by 24 will be equals to 0.042 into Na. Option B will be 1 gram of O2. So in this case is 1 by O2 means 32 into Na. Since there is 2 atom of oxygen in the cells, to multiply by 2, so we'll get 0.0625 into Na. In option C, 1 gram of lithium it is there, 1 by 7 into Na into 1, which is equals to 0.143 into Na. And D is 1 gram of Ag, 1 by 108 into Na into 1, which is equals to 0.0093 into Na. So looking to all this answer for each option, we got maximum number of atom in case of lithium. So option C is the right answer, which is 1 gram of lithium. Okay, dear student, let us see this question. We need to find out the maximum number of water molecule in the given option. Let's take A, 1.8 gram of water. So it will be 1 by 8 divided by 18 into Na in terms of molecule. So that is 6.022 into 10 to the power 23 molecules is there. So the maximum will be 0.1 into Na. So in option B we have 18 gram of water, which is 18 by 18 into Na in terms of molecule, will be 1 into Na. C will be 18 mole of water, so it will be 18 into Na in terms of molecule. And D is 18 molecule of water, which is 18 molecules. So if you see the option A, B, C, D, maximum number of molecule is in case of option C. So answer is option C. Let's do the next question. Question number 2, where assertion says 1.231 has three significant figures and reason says all numbers right to the decimal points are significance. So with respect to this assertion and reasons, we need to choose the appropriate option given below, that is A, B, C, D. So in assertion 1.231 has three significant figures, it is given there, but It is not the correct one because it has 4 significant figure, that is 1 2 3 and 1 it is there. So it is total 4 significant figures are there. So assertion is wrong. Now reason, let's see. All numbers right to the decimal points are significant. So after decimal point all numbers are significant, so that is right one. So reason is right. So if we see the assertion is wrong and reason is right, the option will be C, that is A is not correct but R is correct. So option C. Okay, we will see the next question, that is to find out the number of significant figures for the 3 numbers 161 centimeter, 0.161 centimeter and 0.016 centimeter. So which one will be the best option for them? Let's take 161, 0.161 and 0.0161. Since this first number also have a 3 significance, and in this one also 3 significance are there, and this one also having a 3 significant figures are there, because the numbers which is there we used to, this is directly 161, 1613 numbers are there, and in this cases also preceding 0 is not counted as a significant, so 161 is there, and in this cases also 161 is only the significant figure. So the option will be D. Okay, dear students, we are going to discuss the next question, that is 1 mole of carbon atom which is 12 gram, and the number of atom in it is equal to the option given A, B, C, D. It is there. We need to choose the correct one. So you know that it is very simple question which is asked in the NEET 2020 phase 2. You know that we have already we know that carbon 12 is taken to be as a standard reference for the Avogadro numbers, which is always equals to 6.022 into 10 to the power 23. So there is not much more exercises in this question, just you should know that is because you know that carbon 12 is always considered to be as a 6.022 into the 10 to the power 23. So the answer, the option will be D. Okay, let's take this question. So there is 29.2 minus 20.2 and into 1.79 into 10 to the power 5 is there, and which is all divided by 1.37 it is there. So what will be the significant figures in the final answer? So since you know that all these are in the 29.2 is 3 significant figures, 20.2 is also a same one, 1.79 is also the same one, and 1.37 is also same one. That is, they all having a 3 significant figures. So answer, final answer should be in 3 significant figures. Okay, so the answer is 3, that is option C. Okay, next questions which we are going to do is to find the average atomic mass of the naturally occurring element X, whose isotopic composition is given here, and it's very interesting question. Let's see. So to find out the average atomic mass, we will multiply 200 to 90% plus 199 into 8 divided by 100 plus 202 into 2 divided by 100. So it will be 180, 15.92 and 4.04. So if you add 199.96, which is approximately equal to 200 AMU. So option is D. So simple answer. Okay, third questions which we are going to do is the statement 1 is given the average atomic mass of boron in the periodic table is 10.81 AMU, and statement 2 is B11 is dominant average atomic mass of boron. So from the option given below A, B, C, D, we need to take the correct one. So let us find out the correct statement. Let's say statement 1, which says that is the boron is having a 10.81 AMU as the atomic mass. So we know that there is an existence of boron 10 and boron 11, isotopic form of boron. So now you know that 10 boron is about 19% in the earth crust and 11 boron is about 81%. So if I find the average atomic mass, it is 19 into 100. Okay, 19 into 100, 19 into 10 divided by 100 plus 11 into 81 by 100. So if we calculate, we'll get 10.81. So it is matching with the statement 1, which is 10.8 AMU. So this one is, the statement 1 is right one. Okay, so statement 1 is right. Statement 1 is correct. Let's see statement 2. So according to the statement 2, it says that boron 11 is dominant. So it is also correct because boron 11 exists as 81% in the earth crust. So that's why second statement is also correct. So option A is the correct one, because A says that both statement 1 and statement 2 are correct. Okay, here comes to the next question. It seems to be very tricky question, but it's very simple question. Let me explain you. We know that the specific volume is given as 6.02 into 10 to the power minus 2 cc per gram. The radius is given how much? Radius is 7 Armstrong, it is given. If we convert into the centimeter, it will be 10 to the power minus 8 centimeter. You know that 1 Armstrong is equals to minus 8 centimeter. So length is also given, which is equals to 10 Armstrong, or we can write minus 8 centimeter or 10 to the power minus 7 centimeter. So volume of cylindrical virus is equals to pi r squares, because cylindrical virus means cylinder formula will be PYQs, that is pi r square h, 22 by 7 into 7 into 10 to the power minus 8 centimeter square to the power 7 centimeter. So if we solve all this, we'll get 154 into 10 to the power minus 23 centimeter cube, because centimeter square will be there and centimeter, so it will be centimeter cube. So we got the volume of the cylindrical virus. Now we'll have to find out the molecular weight. So for that, molecular weight will be volume of cylindrical virus into Avogadro number divided by specific volume. So it will be 154 into 10 to the power minus 23 centimeter cube into 6.023 into 10 to the power 23 mole inverse divided by specific volume is given 6.02 into 10 to the power minus 2 centimeter cube per gram. So this will be cancelled, and we will get, this will also cancel one times, 154, this will also cancel, 10 to the power 2 gram will goes and off, will give gram and mole. So since we need to find out the answers in the kilograms, we know that 1 kilogram equals to 10.3 gram. So we'll rewrite the answers as 154 into 10 to the power 2 into 10 to the power minus 3 kg per mole, converting the gram into kg. So it will be 15.4 kg per mole. So hence option will be option A is the right answer. Okay, we have a next question, that is statement 1 is avogram is equal to 1 avogram is equals to 10 AMU, and statement 2 is 1 avogram is reciprocal of Avogadro number. So whether it is right or not, let's see. That 1 avogram is equals to 1 AMU means statement 1 is false. Second statement, that is avogram. So avogram it's not equals to Avogadro number, because it is equals to 6.02 into 10 to the power 23. So both statements are false, hence option C. Okay, let's take another question. So we know, according to questions, 0.5 mole of solute will have how much milliliter of solvent or gram of solvent. So you know that 1 mole solution means 1 mole of solute in 1000 gram of solvent. That means if I consider 0.5 mole of solute, it will be 500 gram of solvent. So it is B. Option B. Okay, now take this one question. Here what we have to find out, that the value of 1 liter of oxygen contain N molecules at 15 degrees Celsius, 150 mmHg. The oxygen and SO2 molecular mass is also given here, 32 and 64. Under the same condition of pressure and temperature, what will be the value of SO2 in 2 liter? So since we know that, according to the question, that at 15 degrees Celsius, the molecule is having same pressure, that is 150 mmHg. That means 1 liter of oxygen equals to 1 liter of SO2 will have the same number of molecules, that is N. That means 2 liter of SO2 means 2N. It's very simple, hence option is C. Okay, let's consider the second question, that is what we have to find out. By heating 20 gram or 20% pure limestone, how much carbon dioxide is produced? That we have to find out. So option is 1.76, 2.6, 1.32, 1.12. So we have CaCO3, which is heated 1200 Kelvin to get CaO plus CO2. So since we know that the molecular weight of CaCO3 is 100 gram, molecular mass, atomic molecular mass can be 100 gram, and it is 44 gram. So 100 gram of CaCO is giving 44 gram. So here 20% of 20 gram or 20% of pure limestone will be 20 divided by 100 into 20, which is equals to 4 gram. So how much it is going to produce carbon dioxide in 4 gram? So the value of X will be 4 into 44 divided by 100, which is equals to 1.76 gram. So option A. Okay, we have a question. A mixture of gases contains H2 and O2 gases in the ratio of 1:4 weight by weight. What is the molar ratio of the two gases in the mixture? So the given is H2 ratio O2 is 1:4 ratio by weight. So weight by weight ratio is given like this. Molar mass of H2 is equals to 2 into 1, 2 gram per mole. Similarly, the molar mass of O2 is equals to 2 into 16, which equals to 32 gram per mole. Now molar ratio will be mass is equals to 2:32, then which equals to 1:16. Therefore mole ratio is equals to 1/4/16. So 4, so which is equals to 4:1 ratio. Hence option D is the right one. Okay, now let's consider this one. Avogadro number changes from 6.022 into 10 to the power 23 to 10 to the power 20. What will happen? Whether mass will change of 1 mole of carbon, or the chemical species of each imbalanced chemical equation remains same, or the ratio element of each other in a compound will change, or definition of mass in the unit of gram. So during these changes, we see that there is change in the number of particle, that is 6.022 into 10 to the power 20, means 10 to the power 23 to 10 to the power 20. So number of particle is changing, so that's why its mass of 1 mole will also change. Also changes. Other, that is chemical equation in the balance species in the balance equation will remain same, because whenever there is a change it will counteract to balance the reactant and the product, so it will remain same. The ratio of the element to each other in a compound will also remain same, because when it is changing and it is balancing, it will remain same. And the definition of mass of unit of gram is independent term, so that's why it is not applied. So the option will be A. Okay, let's take this one question. Here what we have to do, out of four option, which one will have the maximum number of molecules? Okay, so let's see one by one. 18 ml of water. In this case, let's density is equals to 1 gram per milliliter is the density of water. So mass will be density into volume. So 18 ml into 1 gram per milliliter. So ml will cancel. 18 gram will be the mass. So mole will be 18 gram by 18 gram per mole, which is 1 mole. Let's take B, 0.18 gram of water. So here 1 by 18 gram per mole, which equals to 0.01 mole. C will be 0.00224 liter of water, where 1 mole is always equals to 22.4 liter. That means X mole is there for the 0.00224 liter. So X is equals to 0.00224 divided by 22.4, which is 10 to the power minus 4 mole. Okay, and the last one, D will be 10 to the power minus 3 mole. I think it is there. So if I compare all this, the maximum will be the 18 ml of water. So option A is the right one. Okay, now let us consider this question. We need to find out the molecular or atomic weight of X and Y from the molecule given XY2 and X3Y2. So according to the question, 0.1 mole of XY2 is 10 gram and 0.05 mole of X3Y2 is 9 gram. So which means 0.1 X plus 2Y equals to 10 and 0.05 3x plus 2y equals to 9. So if we multiply, we will get 0.1x plus 0.2y equals to 10. and again it will be 0.15 x plus 0.11 y is equals to 9. Let's take this one as equation and equation 2. So we need to equate this one. So what we will do, multiplying equation 1 by 0.5, we get 0.05 x plus 0.1 equals to 5, and 15x plus equals to 9, minus minus, so it will be minus 0.1 x cancel minus 4, so x is equals to minus 4 divided by minus 0.1, which equals to 40. Okay, now taking equation 1, 0.1 x plus 0.2 y is equals to 10, so 0.1 into 40 plus 0.2 y is equals to 10, so only 4 plus 0.2 y is equals to 10. 0.2 y is equals to 10 minus 4 will be 6, so y is equals to 6 by 0.2, so it will be 30. So x is equals to 40, y is equals to 30, hence option A is the right one. Okay, here comes to another questions. We have already done the same type of questions, but it is given in the mass. Let's say question number 12, 7 gram N2, which means 7 by 28 into Na in terms of molecules will be 0.25 something will be there into Na. B will be 2 gram of H2, 2 by 2 into Na molecules, so 1 into Na. C is 16 gram of N2, 46, so it will be 0.347 into Na. D will be 16 gram O2, 16 by 32 in terms of molecule, which is equals to 0.5 into Na. So if you see all these options, option B is the right one. Okay, in these questions what we have to find out, we have to find out the number of atom in 0.1 mole of triatomic gas. So we need to find out 0.1 mole of H3 gas, let's say. So number of atoms, what will be the number of atoms? Na is given 10 to the power 23 mole inverse. Okay, so we know that the formula of number of atoms is equals to given weight by molar mass into another number into atomicity. So this question we have already done also. So W by M means mole, number of moles, that is N into Na into atomicity. So N is 0.1 into 6.023 into 10 to the power 23 triatomic, so by 3. So if we multiply all this, we'll get 1.806 9 into 10 to the power 23 mole inverse. So option B. Okay, now see this question. Volume occupied by one molecule of water should be equal to what? That is A, B, C, D is given. So we have given density of water, which is 1 gram per centimeter cube. Actually it should be minus, okay, no, not minus here, centimeter cube. So density is this much. 1 mole of H2O is always equals to 18 gram per mole, which is equals to 6.022 into 10 to the power 23 mole inverse. Now we know that weight can be written as 18 gram per mole divided by mole inverse. So if you cancel, we get 2.989 into 10 to the power minus 23 gram. So it is almost equals to 3.0 into 10 to the power minus 23 gram. Now we need to find out the volume, no? So we will see here, volume is equals to mass by density. So mass is 3.0 into 10 to the power minus 23 gram, divided by density is 1 gram per centimeter cube. Equals to 10 to the power minus 23 centimeter cube. So option C. Okay, here we have another questions. This type of questions we have already done also, but let's see which one will have the highest number of molecules. In terms of molecules, that is 6.022 into 10 to the power 23 molecules can be considered as an Avogadro number. So let's see, first 15 liter of H2 gas at STP, that is 22.4 liter of H2 is equals to 1 mole. That means X can be 15 by 24 liter, which is equals to 0.67 mole into Na in terms of molecule. B will be 5 liter of N2 gas at STP. So 22.4 liter of N2 is equals to 1 mole. So X can be written as 5 by 22.4 into Na, which is equals to 0.223 into Na in terms of molecule. Now in C, 0.5 gram of H2 gas, which is 0.5 by 2 into Na, 0.25 to Na, and D is 10 gram of O2 gas, 10 by 32 into Na equals to 0.3125 into Na. So if we see all the option, that is 0.67, 0.223, 0.25, 0.3125. That means the option A will be the highest one. So hence option A. Okay, now let us come to the next question. We need to find out the minimum molecular weight of the peroxide anhydrase enzyme. So to do this, let the weight of enzyme equals to x. Then we know that given is weight of SE in x gram of enzyme equals to 0.5% of x, means 0.5 divided by 100 into x. So then the weight of SE in x gram of enzyme equals to 78.4, which is also given here. Now to find out the value of x, 0.5 by 100 x equated, it equals to 78.4. So x is equals to 78.4 into 100 divided by 0.5, which is equals to 1.568 into 10 to the power 4. So if you see this option, then the option D. Okay, let us come to the another question. This question came in AIMPT 1995. We need to find out the number of moles of oxygen in 1 liter of air containing 21% of oxygen by volume. So we know that 1 mole of oxygen is equals to 22.4. This one is a fixed one, that is constant value. So x mole of oxygen equals to 1 liter. So that is 1 liter. So how much mole it is there in the 1 liter? So we need to find out this one. So it is easy the question. So 1 by 22.4, little will be cancelled. So x is equals to 1 by 22.4 mole. So you know that it is the percentage of oxygen is 21% of oxygen by volume, it is there. So it will be 21 by 100 into 1 by 22.4, which is equals to 0.0093 mole. So option will be A. Okay, dear students, we'll see the next question, that is hemoglobin contains 0.33% of iron by weight and its molecular weight is given, that is 672,000 gram. So we need to find out the number of iron atom in this hemoglobin whose molecular weight is 672,000 and the percentage 0.33%. So let us see. Solution will be total weight of hemoglobin equals to 672,000 gram. Now the iron content is about 0.33%, it is there, which means weight of iron is 0.3300 out of 672,000. So if we cancel and multiply it, we'll get 221.76 gram of iron out of 672,000 gram of hemoglobin. Therefore, number of iron atom is equals to 22176 gram divided by 56 gram, which is equals to 3.96 or equals to 4. So option C is the right one. Okay, we'll see another type of questions. We have assertion equal moles of different substance contain same number of constituent particle, and reason is equal weight of different substance contain the same number of constituent particle. So we know that equal moles is equals to same number of constituent particle, hence assertion is right. And equal weight of different substances, it's different number of constituent particles. That means reason it's not right. Okay, so only the assertion is right, because equal mole is always equals to same number of constituent particle, but equal weight cannot be same number of constituent particle. That's why the option is A is correct, R is not correct. That is option B. Okay, let us see the another question, very interesting question. That is, we need to find out the total number of valence electron in 4.2 gram of N3 minus ion. We know that 1 mole of N3 minus ion is equals to Na. So 4.2 gram of N3 minus ion means 4 by 2 divided by 42, which is equals to 0.1, means that is moles is equals to 0.1 Na. So total number of valence electron in N3 minus ion equals to 5 plus 5 plus 1. You know that there is the 5 is the outermost electron in case of N, so there is 3 5 it is there, 3 N it is there, so 3 into 5 means N minus it is there, so plus 1 will be there, which is equals to 16 valence electron it is there. So total number of valence electron in 4.2 gram equals to 0.1 into Na into 16, which is equals to 1.6 Na. So option C. Okay, dear students, another question is very easy question. That is, we need to find out the percentage of zinc in the white vitriol. The formula of white vitriol is also given. So what we have to do, we have to find out the molar mass of the white vitriol, that is ZnSO4 7H2O. So that is 65 plus 32 plus 16 into 4 plus 7 into 2 plus 16. So together it is going to give 287 as the atomic mass, molecular mass of this zinc sulfate heptahydrate. And you need to find out the percentage of zinc. So zinc is how much? 65 it is there, 287 into 100, which is approximately 22.65. So option is D. Okay, dear students, let us see the next question. In this question, we have to find out the empirical formula of the compound, where carbon is about 78% by weight and remaining is hydrogen. So 100 minus 78 means it is 22%. So if we calculate the mole of carbon 78 by 12, which is equals to 6.5 mole, and hydrogen is 22 by 1, it is 22. Now simple ratio is we have to take the smallest one, that is 6.5 is the smallest one. So if divided by 6.5 and 6.5, it is 1, and in this cases 22 divided by 6.5, which is equals to 3. So empirical formula will be CH3. So our option is D. Okay, let us see the another question. That is number of gram molecule of oxygen in 6.02 into 10 to the power 23 CO molecule each. So given each, that is we know that 6.023 into 10 to the power 23 molecule means 1 mole of CO. Similarly, if the value which is given here 24 molecules, there will be X molecule. Let's X molecule of CO. So X will be 6.023 into 10 to the power 24 divided by 6.023 into 10 to the power 23. Cancel. So X will be 10 mole of CO. So we know that from the given value, the carbon and oxygen are in the equal number, that is the atom of carbon and oxygen are same. So 10 mole of CO means there is a 10 mole of O atom, that is 10 gram of oxygen. So number of gram molecule of oxygen is equals to gram atom of oxygen divided by 2. So 10 divided by 2 will be 5. Therefore 5 gram of molecules of oxygen are present in 6.022 into 10 to the power 24 CO molecules. So the option will be 5 gram, means option B. Okay, let us see the another question where we have to find out the number of moles of hydrogen molecule to produce 20 mole of ammonia in Haber process. We know that in Haber process nitrogen react with 3 molecule of hydrogen to give 2 molecule of ammonia, means 1 mole, 3 mole and 2 mole. So for this question 2 mole of ammonia require 3 mole of hydrogen. So means 1 mole of ammonia require 3 by 2 mole of hydrogen. So if 20 mole of ammonia is there, then it will be 3 by 2 into 20, means 30 mole. So 30 is option B. Okay, this question is very easy. Let's see this one. So you know that A molality means number of moles of solute divided by mass of solvent in kg. So that means it is independent of the temperature because mass of solvent it is there. B is molarity. It is number of moles of solute divided by volume of solution in liter. So volume of solution in liter it is there. So temperature dependent, it is volume is mentioned, so that's why this one is dependent on temperature. Mole fraction is number of moles of solute divided by N total. It is also independent of the temperature, so it is not the option. With percentage, it is mass of substance divided by total mass into 100. So this is also not dependent on temperature, so option B is the right one. Okay, dear student, let's see the next question. When 22.4 liters of H2 is mixed with the 11.2 liter of Cl2 each at STP, the moles of HCl form equal to. So here the reaction is H2 plus Cl2 is going to give 2 HCl. Okay, this is 1 mole, 2 mole. Means 1 mole of H2 react with 1 mole of HCl to gives 2 mole of HCl. So 1 mole is always equals to 22.4. Here 2 into 22.4. But when it is 22.4, it is 11.2. It used to give 22.4. Why? Because those which is having the lesser number in quantity is considered to be as a limiting reagent, because Cl2 act as a limiting reagent. Hence, product depends on limiting reagent amount. So 22.4 is giving 2 into 24, then means 11.2 will give 22.4 only. Hence option is A. Okay, we have a question to see whether assertion and reasons are right or not, and to choose the option A, B, C, D, the correct option. Okay, let's see whether the mole fraction of solute is 0.0177 or not. So you know that 1 molar aqueous solution means 1 mole of solute in 1000 gram of solvent. So N solute is 1 mole. N solvent is equals to 1000 divided by 18, which equals to 55.56 mole. Now N total will be N solute plus N solvent, which is 1 plus 55.56, that is 56.56 mole. Okay, then after let us find out the X solute, which is N solute divided by N total, that is 1 mole divided by 56.56 mole, so will be equals to 0.0177. so that means the assertion is right. And the second reason is given the molar mass of water is 18 gram per mole, so that is right. Reason is also right, because molar mass of water is 18 gram per mole. But as per the assertion which is given here, reason is not the correct explanation. It only says that it is the molar mass of 18 is 18 gram per mole, so that's why the option will be A. That is, both A and R are correct, but R is not the correct explanation of the A. Okay, dear student, let's do next question. Here we have to find out the remaining product after the reaction of formic acid and the oxalic acid with the mixture of formic acid and the oxalic acid with the concentrated sulfuric acid. So first of all, let's find out the molar mass of formic acid, which is 2 plus 12 plus 16 into 2 plus 1, so it will be 46 gram per mole. And molar mass of oxalic acid will be 90 gram per mole. Okay, then let's see first formic acid which has been reacted with the concentrated sulfuric acid. After the reaction with the concentrated sulfuric acid, it used to give carbon monoxide and water. Now its mole is equals to 2.3 gram divided by 46, which is 1 by 20. Means 1 by 20 was there in the beginning and it was 0 in the beginning. So after the formation of CO and water, it became 0 and it is 1 by 20 and 1 by 20. Okay, then after, for the oxalic acid, concentrated sulfuric acid, it is reacted, so it used to give CO2 plus H2O. Okay, so its mole also, as per the given value, 4.5 divided by 90, which is 1 by 20 again. So 1 by 20, 0, 0, 0 in the beginning, and that's 0, 1 by 20, 1 by 20, 1 by 20. Okay. Now in these cases, the remaining product will be, so you know that in both the cases, water is consumed by sulfuric acid. So water is, the value of water 1 by 20 is being consumed by the sulfuric acid. CO2 is absorbed by the KOH pellet. So only the remaining is, in both the cases, is CO, both the CO, which is 1 by 20 plus 1 by 20, that is 2 by 20, which is 1 by 10. Okay, so this is one value. So remaining mass of CO will be CO is equals to molar mass into moles, that is 28 gram per mole into 1 by 10, so which is 2.8 gram. So hence option will be C. Okay, dear students, we will see the next questions. We need to find out the mass of precipitate when 50 ml of 16.9% solution of AgNO3 is mixed with the 50 ml of 5.8% NaCl. So we know that AgNO3 molar mass will be 107.8 plus 14 plus 16 into 3, which together will get 169.8, which can be equal to 170. Similarly, NaCl, which is 23 plus 35.5, 58.5. Similarly, AgCl will be 107.8 plus 35.5, it is 143.3 or 143. So during the reaction, AgNO3 reacted with NaCl to give AgCl plus NaNO3. So as per the molar mass, it is 170, it is 58.5, it is 143. Okay, so actual percentage or amount of AgNO3 as per the given question is AgNO3 16.9 divided by 100 into 50, which is equals to 8.45, or it equals to 8.45 in the gram. Similarly, NaCl is 5.8 divided by 100 into 50, which is equals to 2.9 ml or 2.9 gram. Now moles of AgNO3 goes to 8.45 divided by 170, 0.049, and moles of NaCl is equals to 2.9 divided by 58.5 is equals to 0.049. Okay, then again AgNO3 plus NaCl, AgCl plus NaNO3, where during the starting point it was 0.0049 and it was 0. So when it becomes 0, it becomes 0.049, 0.049. Then AgCl moles equals to W by molar mass means given weight. So weight of AgCl is equals to into 143, which is 7.007 or 7 gram. So option B is the right one. Okay, dear student, let us see the next question. That is, we need to find out the mass of the HNO3, which is used to prepare 250 ml of 2.0 m HNO3. So first, molar mass of HNO3 is 1 plus 14 plus 16 into 3, that is 63 gram per mole. So let us find out the moles of HNO3 in these cases first. So molarity is equals to number of moles of solute divided by volume of solution in liter. So molarity is already given 2.0 m, volume equals to 250 ml, which is 0.25 liter. So putting this value in this equation, 2.0 number of moles of solute divided by 2.5. So number of moles of solute equals to 2 into 0.25, which is 0.5 mole. Okay, so moles we have find out the solids. Now number of moles of solute is given weight by molar mass. So from here we can find out the given weight. Number of moles we have already found out, that is 0.5 into molar mass is 63. This is 31.5 gram. So weight of HNO3 is 31.5 gram. But this 31.5 gram which is given here has the purity of 70% only. So what about the 100% purity? Let's say x gram. So x is equals to 31.5 into 100 divided by 70. So x is a 45 gram. So the value of x is 45, means HNO3 is 45 gram in the 100% concentrated HNO3. So option is A. Okay, dear student, let us see this the question. 1 gram of magnesium is bound with 0.56 gram of oxygen in a closed vessel. Which reactant is left in excess and how much? So we need to find out the reactant which is left in excess and how much. So we know that in this reaction, Mg reacted with half mole of oxygen to give MgO. So 1 gram of Mg is given and 0.56 gram given. Now we need to find out the moles of Mg. Moles equals to 1 by 24. So which is 0.0416. Let's see this one, moles. Similarly, if I take the oxygen, O2 is equals to 56 divided by 32. It will be 0.175. mole, 0.0175 moles. Now from this value we know that oxygen is limiting reagent. So mg moles of mg reactant equals to 0.0175 into 2, which is 0.035 moles. Okay, then after mg left edge equals to 0.016 minus 0.035. It will be 0.0066 moles. So this one is the unreacted part. So we need to find out the mass of this unreacted part. So mass is equals to molar mass into moles into 24, which is 0.1584. So approximately it is 0.16. So if you see the option, then it will be first one. That is gram mg.